In this webinar, we talk about best practice about bind9 logging for authoritative servers, for DNS resolvers, some words about file system best practices around bind9 log files, especially transparent online compression. We look at modern tools to filter through large log files such as ugrep or ripgrep. We have a look at Linux and systemd journal and how that can help with maintaining the log files and filtering and finding stuff in the log files. Something that I often do is I identify hotspots in the log files using histograms, and I show you some examples how that works. And I've written a few simple tools called the log eater tools that I personally use to condense information from large bind9 log files, and I make these tools available as open source, and I will give you some examples how to use them. And then we look at atop, which is a system monitoring tool that also has historical data. And last but not least is a system for incident-based TCP dump and DNS traffic captures. So let's jump right in. So from my point of view, bind9 has one of the most flexible logging frameworks that can be found in any Unix or Linux server products. We have the categories that define what should be written to the logs, so what information, what content should end up in the logs. And then we have the channels that define where the data should be written to. And we can mix and match the categories to the channels. So there can be multiple categories that are written to the same channel, or we have one category that is written to multiple channels. Now that sounds difficult to understand, so I have a small picture here. So first we have the channel, which define where to log, and that can be to syslog, or it can be one or more files on the file system. It can be to the null channel. Everything going to the null channel will be thrown away. We do that for content that we don't care about. And it can be standard error, which will then be written to the standard error file descriptor. And that is usually of use if the bind process is running under supervision from another process, for example, with systemd, but also with other supervising tools, because these tools that are supervising, they can then catch the log output and do something with that. And we will see how that works in the case of systemd. And then we have the categories, and there are about 30 categories in bind9. They define what we would like to log, something like security, everything that is related to security, zone transfer incoming, zone transfer outgoing, the queries received by the DNS server, messages and issues around DNSsec. And then there are a few catch-all or pre-configured categories like default that should help beginners with bind to select a reasonable log configuration by just selecting that category. And once we have defined categories and channels, we can, in the configuration file, combine them. So as you see here, we have multiple categories logging to syslog, security, DNSsec, and the default category. All three, they log to syslog. The zone transfer, xfer in and xfer out categories, which are both their own category, they log into the transfer log. And the default on the bottom, on the right-hand side, that category logs to both standard error and to syslog. So it's a quite flexible system. So some best practices from my point of view, what I do when I install larger bind name servers is to separate all the log categories that have many, many entries per day from all the categories that have only a few entries per day. So something like resolvers or layers, where on a big DNS resolver, you have maybe thousands of log entries per day on a busy name server. These should go into their own files. And then there are some other categories where you only see occasionally a log entry, maybe once or twice a day, maybe once a week. They could be combined with others into a different file. For example, what I like to do is to put everything that is related to a zone transfer on an authoritative server into one file, something like the extra in, extra out, and the notify, because notify is something that has to do with zone transfer, put that into the zone transfer or transfer.log, or combine all the categories updates and update security into a log. When you combine multiple categories into one log file, make sure that you use the configuration statement print category yes, because then bind will print the category into the log file, into the log entries, and you can then filter on the categories later in the combined log files. Bind9 supports the syslog priorities or severities, something like debug info, warning, error, fatal, and so on. And that is also supported when writing to a log file, not only when using syslog. The severities work in a way that if you select severity, then all messages of that severity and higher will be logged. So if you select warning, also error and fatal will be logged. If you select, for example, info, it will also contain then error and fatal and so on. Again, similar to the categories, you can use the logging statement print severity yes to print the severity into the log files. And that, again, allows for later filtering based on the severity. And here we see an example of a log file with the severities enabled and the categories. So these general and query errors, these are the categories. And then the next column, info and notice, these are the severities. And then after that comes the message. I would like to mention the RPZ logging here. RPZ is a logging category for the response policy zone activity on the server. Response policy zone is a system in Bind9 to be able to rewrite DNS queries or answers. And this is often used to block malware on a DNS resolver. And when enabling the RPZ logging, you can see in the log files which names are subject of rewriting and what kind of rewriting happens here. So in these examples, we see the IP addresses of the clients that sent the query. In this case, it's all IPv6 addresses. Then the domain name that have been rewritten. So for example, trojan.biz. And then what kind of rewriting had been done. In this case, it was a QName path-through rewrite. And that entry was found in the trojan.biz Trojan RPZ zone. So this RPZ logging gives you a nice overview of how RPZ works, how good it works, and if it catches all the intended bad domains. So for this webinar, I've created a logging configuration template for Bind9 for both authoritative servers and resolvers, and they are linked here. The reason for the extra page is that the logging configuration doesn't really fit nicely on a slide. And I plan to keep this page online and update that from time to time. For example, if new versions of bind been released with new categories or new features in there. So keep in mind, this is just a template. So probably you want to use that as a starting point and then make changes to fit your environment. So this is for the template for an authoritative server. There's one general channel called named that is kind of a catch-all for everything that is not particularly selected for its own log file. And we keep in 10 versions, each 20 megabyte. Severity is info and up. I usually just log info and everything and have the print severity on so that I can later filter on the log files. With print time, ISO 8601 UTC, the timestamps in the log files are easily parsable by programs because they are in the format year, month, and day. That makes it easy to like sort by date or even like parse the date from a program like from Ruby or Python or your favorite scripting language. And it's always UTC, so it makes it then easy to correlate events across multiple servers that might be located in different time zones and might not have that time set to UTC. And then for the named channel, the print category is on. It's yes, because there are multiple categories that go into that file, and the print severity is on. For all the others, because they are dedicated log files for special topics, there I don't log the categories in there. Security is everything security related. Rate limit is about the rate limiting. Query log, I come later to that. Query logging, what to be careful about there. Transfer log is everything about the zone transfer in and out, and then the update log is the dynamic updates. And below that is a similar template for a DNS resolver. The logging template for the resolver is a little bit more complex, but you might not need everything in there. For example, if you don't have response policy zones, you don't need to have the RPZ logging in there. Also, in some instances, lame server logging or query logging might not be needed. So going back to the slides, talking about query logging. So bind 9 allows to write a log entry for every incoming query. And that log entries will list the IP address of the sender, the domain name in the query, the record type being queried, and information on the flags, something like DNS OK, whether eDNS is being used, recursion desired, request over TCP, and so on. And we have an example here. We see the timestamp, and this is the ISO timestamp format. We see client information here, the IPv4 address and the port number, the domain name being requested, then the domain name itself, what the full record with network class and the record type. In this case, it was a Quad A record, and it was a non-recursive query, which is the minus here. And there was nothing special about that. It wasn't signed. It was no eDNS there. And it has been received on the network interface with this IP address on the name server. So if you have a name server with multiple network interfaces and bind is running on more than one of these network interfaces with this logging entry, you see on which interface the query has been received. That might be interesting for a split horizon DNS resolver, where there are queries coming from inside reaching the DNS resolver or the authoritative server from an inside network, and queries also can come from the outside. Enabling query logging is very time consuming for a DNS server. And it's less writing the data down to disk, because some people say, oh, I have a fast SSD, so having query logging on all the time shouldn't be a big problem. It is actually more the work that the bind name server needs to do to convert the binary data into human readable text. And that is what is CPU intensive. So if you enable query logging on a busy DNS server, and I would say busy is anything around 500 queries per second, that can reduce the performance of the DNS server and increase the latency of the DNS answers, because bind will first write the log entry and then send the answer out. So my recommendation is to have query logging configured, but not enabled by default. Instead, you will enable that when you do troubleshooting, when you look for certain issues with your name server, and then you enable that, you do the troubleshooting, and later on you disable that again. And be careful enabling query logging during high times of your name server. So you probably want to do that when the name server is not under full load. In order to make sure that query logging is switched off whenever you restart the bind process, in the option block, you should have the statement query log no, because that will switch off query logging when restarting or reloading the name server. If you don't have that, it might happen that when you just restart or reload the bind name server, that it comes up, starts up with query logging enabled. There are alternatives to query logging. For example, the bind 9 query logging only gives you information about the query, but not about the answer being sent out. And the alternatives give you more information. The most convenient solution from my point of view is DNStab, which is a special binary protocol that is supported by many DNS servers out there. And it's also supported by bind. And that is able either to write the binary logging information to a file, or even send that over a socket over the network so that it can be consumed on a different machine and then analyzed there. And there is a block entry in the knowledge base that explains how to use DNStab with bind. Also, even the DNStab is not as performance critical compared to query logging, because the DNStab runs like asynchronously with the bind operation. So if DNStab cannot digest all the data because it's just too much coming in, it will not slow down bind sending out the answers, the replies. It will just then skip some data. But still, if DNStab is enabled, it takes some CPU cycles from the main machine. And if you have a bind server that is already quite busy and all the CPU cores are good utilized, you should be careful having DNStab on all the time. So what I usually do is I configure DNStab and I enable that when needed on demand and disable that later on. And as part of the this webinar, I will show you my system to automatically enable DNStab whenever some incident occurs. And the other option is to use some PCAP or TCP dump-based passive DNS collection. There are many open source tools available. There's this one from the French registry, AFNIC, called DNSmezzo. There's also other tools from DNS.org that can be used. And these tools, they sniff on the network layer and write down all the DNS queries and the responses sent out by the DNS server. And the nice thing about PCAP-based passive DNS data collection is that can be done on a completely isolated machine. So it doesn't need to be on the DNS server itself. It can be a different machine. So it has no performance impact whatsoever on the bind name server. So some words about file system and logging best practices there. Nowadays, modern Unix and especially Linux systems, they propose a single partition install. In the older days of Unix, you had all these small partitions, one for the root partition, one for home, one for USR, one for var, and so on. And then even below var, there are maybe multiple sub-partitions in there. And because quite a number of people struggled with that concept, and also because hard disks nowadays tend to be quite large, the solution was to default to a single partition install, where the installation program just creates one large partition on the hard disk. Which is good if you run Linux on a desktop or on a laptop, but it increases the risk that the operating system partition, the root partition, is running full, and bad things can happen once the root partition runs full. Logging stops, but also it can be that the bind operation stops because, for example, bind can't store incoming zone transfers anymore. It can't store DNS signatures, or it cannot reassign zones. So this is something that should be avoided at all costs. The root partition, especially the partition where bind keeps its zone files and additional data, should never run out of space. And the main culprit when the root partition runs out of space is logging. Administrators configure logging, and either there's a problem with log rotation or they don't configure log rotation. So the system just logs and logs larger log files, and at some point of time, the root partition is full. So my recommendation here, even if you don't want to have this fine-grained multi-partition setup that have been used in the past with Unix and Linux, create at least one dedicated large enough partition for the log files and mount that into var log or wherever the bind name server writes its log file. Tools like log rotate can help by compressing old log files. Bind 9 itself can do log rotation, but bind 9 itself doesn't do the compression. However, as mentioned, disk space is seldom a problem today, at least not generally, partition problems aside. So what I like to do is work with online compression. So because working with manually compressed log files, like with gzip or zstandard compressed log files, it's more difficult to work with them. It's more difficult to filter data from them because you have to first temporarily uncompress them, then filter, then compress them again, or remove the temporary file. So if the system allows, I use a file system like Btrfs or ZFS. Both offer excellent transparent online compression. So the data will be compressed when written to the storage. And whenever you read the data, it will be transparently decompressed. And that can even speed up the I/O performance, because nowadays CPUs are faster compressing the data than the storage subsystem is writing that to the storage. So if there's less data to be written to the disk, to storage, it might be faster when it is compressed. So logging with systemd journald. As you know, modern Linux systems come with the systemd process management system. And that includes a database for log information called the journal, something that has the plan to replace syslog in the long run. The systemd journal can either be stored locally, meaning on the same machine as the service or bind name server runs, or it can be on a remote machine, which would be a central journal server, very similar to remote syslogging. What are the benefits from my point of view for a systemd journal for using that compared to syslog? Now, it automatically can correlate log entries from different sources, for example, from systemd startup, from the network stack, from the Bind9 server, and so on, which is possible with classic text-based log files, but it requires some tooling. That comes out of the box with systemd. It's more easily to filter log information because it's not a plain text file. It's actually a database with a structure in there. So you have structured fields for time, for servers, for different keywords, and you can filter on them. It's possible to output the log entries after filtering into text and different flavors. For example, you can write that down to a verbose text representation. You can write that down to JSON in order to import that into a written script, or it can be exported in binary. On a central journal host, it is possible to merge the log information from multiple hosts, and by that I mean intelligently merge that. Of course, it is also possible with syslog, but syslog just writes the log entries in a merged log file, while with systemd, it's there possible to merge and just select one service, like give me all messages of severity error from all my bind processes around, from all my resolvers, and there might be 20 resolvers out there. The remote logging can be via push or pull configurations. With syslog, we only know push. Push means the machine running the service pushes the data out to the central log host. That works also with systemd, but also systemd knows about a different configuration called the pull configuration, where the central host makes the connection to all the service machines and pulls the log information. And that can even be done to certain intervals, so like hourly or daily, so that there's not an online connection between the service machine and the logging machine all the time. Instead, the log content is being pulled from time to time. It supports online compression, so there's no need to have file system compression or something like log_rotate to compress log files. And for security, that's interesting, it supports forward secure sealing, where in a cryptographic way, every log entry is being dependent on previous log entries. And that can be verified with the tooling available in systemd. So it makes it impossible for an attacker to remove log entries, or not. It's not impossible to remove the log entries, but it's impossible to do that without being detected. Because the systemd has something like a chain across all the log entries, and that chain can be verified. And if one log entry or log data is being changed or is being removed from the journal, that chain is broken, and it is all it's immediately visible that the data is not trustworthy again, that it has been tampered with. And that works locally, and that also works over the network to a central log host. So in order to use systemd from Bind9, Bind9 needs to be started from a systemd service unit. And systemd then will capture the information written to standard out or standard errors channel of the Bind9 process and write the information into the journal. So if you want to have specific logging information to be written into the journal, you have to configure Bind9 in the logging configuration to write that log categories to standard error. So now we go to a short live demo, and I need to switch over and share a different screen. So here we are. So we need this window here. So this is a Linux system which has a bind server running. And this is a small toy system. It's not an important system, and so I can show that live here. So we see that bind is running here. And if we call systemctl status, we see the last entries of that are the last log entries that have been written to the log files. And here it's mostly about a bad zone transfer request and some denied queries to the cache. If we want to directly get information from the journal, we use journalctl -u for unit, and then the name of the unit. This here is a Red Hat-based system, and in a Red Hat-based system, the bind9 unit's name is named. In Debian-based systems such as Ubuntu, it's called bind9. And if I call journalctl just with -u and then the name of the unit, I get all the log entries from the very beginning. This log starts here on February the 13th. And now I can scroll down to view the log files. But yeah, that is not very spectacular. It's more interesting to do some filtering on there. For example, I can filter with --grep, filter for any keyword in there. And let me filter for trust. And now I see only the log entries that contain the string trust, like in trust anchor telemetry or in it's no trusted. And as the --grep indicates, it's using the same mechanism as grep in the background, so you can use regular expressions there. Sometimes it's interesting to have the newest information first, and you get that with the parameter -r for reverse. So by default, we're getting the oldest log entries first. With reverse, we're getting the newest log entries first. So the log here starts, the last entry is from February 17th at 5:16. We can filter by time. So we can ask, give me all the log entries since, with the capital S. And I use here 2021 February. And I want to see everything from the 16th until 2021 February 17th. And now it starts with February 16th, and the first entry was at 45 minutes past midnight. And then if I scroll down here, it stops at February 16th, a few minutes before midnight, before February the 17th. Of course, all this is possible with grep and org and Perl and all the stuff that you can use to work with traditional log files. But for some administrators, this might be simpler to use. I would like to show you a little bit about the output formats. -O selects the output format, and if we select verbose in the journal, we get not only the log entries, but we get all the fields that are stored in the journal and which we can use for filtering. So the very first log entry starts here, and it has a boot ID, which is the UUID for every boot process on the machine, and it has a unique machine ID. We see the host name. We see over which transport protocol this log entry has been written, the priority, the syslog identifier, the command name, that is the name of the process that wrote the log entry, the executable. So we have the information that it was really user Erskine named and not some named in some other directory. We have syslog facility, the process ID, and the timestamp, then the message. That is what we usually see. And then we have additional information, something like the full command line of the process that is running. We have the SE Linux context, the capabilities that are in effect or were in effect when this log entry was written, and so on. And you can filter on all these fields here to filter down the entries in a log file, which can be very convenient. And if you don't want to process this much data manually, you can write out the data as JSON or JSON pretty. And this gives you basically the same information, the same fields, but in a JSON format, which can then be piped into like a Python tool that can read JSON and can work with this, which makes it much easier than parsing a traditional log file. So back to the slides. So searching and filtering through log files. If you don't use systemd journalD and you would like to work on traditional log files, still it might be good to know that there are some modern tools around that can help with that. So the traditional tools to search and filter through log files are grep, orc, and perl. Over the last years, a number of new tools appeared that have some benefits compared to the traditional tools. For example, these tools have multi-CPU core scalability. So, for example, if you filter a large log file, it can divide the task into multiple parts, divide the data into multiple parts, and then concurrently work on multiple CPU cores. It has some faster regular expression engines than the original tools, has some interactive filter capabilities, and some of them work transparently with compressed files. So you could then grab like on a gzip or xz compressed file. Here are some examples that I sometimes use with the links where you can find them, and I will show you ugrep in a moment. Yep. And what I like about ugrep is that it has this interactive mode. So let me see, this should be the right, yep, this is the right machine. So I use ugrep minus uppercase Q, and then I specify the log file. In this case, it's the var namely log. And it reads in the log file. And it gives me a small Q prompt at the top. And I now can start typing in either normal text or regular expressions. So I can here type config, and it immediately interactively shows me all the lines that contain config, and it does so in the background, so I can still type while it is filtering. It's not I type and then it needs to filter through a gigabyte of log file. It does that concurrently, which is very nice. I can also use regular expressions here. For example, I can ask give me everything that contains config or general with a colon. And now I have all these two categories here. And if I remove general, then I only have the config data in there. And that makes it really nice to just filter for specific domain names, like everything is block. There's nothing with block. What do we have here? Works. Yeah, so there are some domains in the works top level domain that have issues. As the name implies, that is on purpose, and we see all the error messages here. So ugrep with the interactive query sometimes is really helpful to find information in large log files. Back to the slides. So from time to time, I'm being tasked to find the root cause of a Bind9 incident in really large log files. And I've written some tools. I call these the log eater tools to help me with the task. And these are very simple tools. I usually download the tools and then adjust them for the task at hand and then have them run. So they are written in Go, and they're written in Go because Go produces binary, static binaries with no dependencies. So I can compile them on my work machine here on my laptop. I can then secure copy them over to the customer's machine, of course, with permission of the customer. And then I can have them running there without the need to install any dependencies on the remote machine. However, be careful, these tools are being written to work on all available CPU cores. So if you run that on a production DNS server, it can starve the DNS server process by taking all the CPU power of that machine. So be careful about that. Here's some examples. The tool with the most functionality is the log eater queries tool that can go through a query log file and will generate statistics and aggregated information from that file. For example, it can list all the network classes, the domain names, the IP addresses from the queries, some statistics about the file and the query type, like A record, quad A record, NX record, and MX record, and so on, that has been requested. And for the query IP addresses, you can have that either with reverse IP lookup, which is the default, or you can disable reverse IP lookup. And here's an example how that looks like. All the tools take the input from a pipe. So you pipe the data into the tool. Some of the tools have switches like log eater queries. Some don't have switches at the moment because they just have a single purpose. And then the column -T just does a nice formatting in column here. And here we see the query network classes that appeared in that query file and the query types. And here's an example of printing the top 10 query IP addresses with reverse name resolution. So -I is the finding the queries, and then by default it does the reverse name resolution and prints the name of the IP address in square brackets. Log eater DNSsec, I use that to analyze the DNSsec log file that is category DNSsec on a resolver. It doesn't work currently on DNSsec log files on an authoritative server, but it works on a resolver, and it gives me the like top 10, 20, 30 problems or log messages in the log files. And similarly, the log eater resolver goes through the resolver category and groups the error messages there. So it tells me which domain names have the most problems here. And here we see qq.com, which is probably a not quite correct working DNS load balancer on that other end. Yeah, and SonyMusicFans.com gives invalid responses on the DS record. So a little live demo on the log eater tools, how to use them. So I'm here in the directory where I've checked out the log eater tools from GitHub. And let me quickly build the tool. So building the tool is nothing more than called go build and then the source file. And Go being a very fast compiler, it then creates the binary almost immediately. And then
Carsten, you're still sharing the slide?
Oh, sorry. Yes, sure.
Okay. Switch windows.
Thank you.
Sure.
So now you see my terminal. Let me start again by removing the tool. So let's go build logitaqueries.go. That compiles the tool, and it works the same way with the other tools in the repository. And then I do a cut on a query log file. I call logitaqueries, and I want to see all the domains in there and the statistics on the domains. And I want to have the top 10 entries. If you just call logitaqueries, it usually creates a long tail of queries with just one, with domain names that just have been queried once. So usually you want to see the top, like top 10 or top 20 or top 100 of that. And you see it's quite fast, even on gigabyte-sized log files. It usually spits out the result in a minute or two. And here we have the DOH default routes DE, which is by far the most queried domain in this. And then on the second is the fail05 DNSsec.works, and then mailop.org, and so on and so forth. So, and if I want to have the top 20, I just change the head there, and it gives me the top 20 domains being queried from this log file. Quickly show the queries IP address. So -i for the IP addresses, -n for down to reverse resolution, because that can be slow. And these are the top 20 IP addresses that can be found in the query log file. So these were the logiter tools. Another tool that I use is histograms. Histograms, I use them to find hotspots or outliers in log files, especially in large log files. So these histograms tell me where I need to go into the log file to find certain problems. So I don't want to just page through a gigabyte of log files. I want to know around which hour or even which minute a problem appeared. Such histograms can be created from any field in the log file. It can be time-based, it can be based on the query name, it can be based on the IP address or on error messages. And I use classic Unix tools in a shell pipeline for that, but it's also possible to use the logiter tools and just upgrade them a little bit to spit out histograms. So this here creates a time-based histogram of the DNSsec log file. So I just want to have all the entries from the 17th February 2021, so from today. Then the org command prints a certain field, which is the first field in the log file, space delimited from character 0 to 16, which is the full date in the ISO format. Then with the unique, I condense that to unique entries, and then the next org creates the histogram out of that and prints stars according to the number of log files per, I think, per minute that is. And this is how it looks like from a histogram created by that command line just there. And here we see on the 27th of April 2020, there was some incident which started probably around 1816, 1817, and then there was all of a sudden much more log entries for DNSsec related stuff starting there, and then it was slowly declining, and an hour later it was gone. And with this histogram, it was then able for me to just directly jump to that timestamp to 1817 and see what's happening there, instead of just looking through the whole log file. Here's another example. This is the pipe that creates histograms on log messages. So it creates a histogram of the same log messages. And this is how it looks like. The query cache denied for www.google.com has the most entries. It has 100 entries in the example log file. Then peacecorps.gov had 10 entries, and all the others just have 2 entries. So this can also be used to find outliers, some domains that creates problems for certain reasons. So this was about the histograms. I'm almost through the webinar. I just would like to tell you about atop. And atop is a real-time system monitor. It's an alternative to the Unix and Linux top tool. And it has many, many advantages. And the main advantage here is that it shows the TCP and UDP and network bandwidth utilization. It shows CPU frequencies and CPU utilization, and also interrupt utilization, which is important on busy name servers. And it can store historical data in a binary file, and you can later then go into the system and watch what's going on. Here's an example, but let me do another live demo here, because it's really better to show that live. And we need this machine here again. So if I call atop, then it directly shows me the current system status. And you see there's a lot more information here than you see with the top. Here at the top, we see the CPU utilization, we see system and user utilization, interrupt utilization. We see the current frequency, which is 2.29 gigahertz at the moment. We see the load, the memory utilization, which is quite okay in this case. And we see the network interfaces, how many packages, the speed of the network interfaces, the gigabit here, and how much data is flowing in and out, which is almost nothing in this case. But let's say there was an incident some weeks ago, and I can, with atop -r, go into the historical data. Let's say the 30th of January 2021. And it starts here at midnight. And with the key B, I can jump to a certain timestamp. Let's go to 9:00 p.m. And this was a status 9:00 p.m. on 30th of January 2021. And we see the machine had a problem with the memory here. And that is highlighted in red because it has some 127 megabyte of free memory, and it has no free swap. So there's probably some kind of memory leak going on here. When we see this thing, we can, with the keys lowercase t and uppercase t, we can go back and forward in time. With lowercase t, we jump 10 minutes ahead, and with uppercase t, we can jump 10 minutes back in time and see how the system came to this situation and when it started. So it seems to be here, this condition was running for over a longer time, possibly even days before. And you can also filter with the capital P, filter just on a certain process name. Let me filter here on MySQL because maybe that was a culprit, could be. And what's interesting here, if you look for memory problems, the columns vgrow and rgrow, which are the growth of virtual memory and the real memory growth. So virtual memory is the allocation and real is the memory that is really being used by the process. Let me see if we have some situation here where that changes. Do we have something? Do we have named here? Yeah, here we have named running, and we see at 1340 that time it shrunk by 240K. So it gave memory back. With this, you can watch for processes that run away and always grow and never shrink back. Also interesting is the second column, the CID, which is the container ID. If you have a machine with Linux containers, you see in which container context the processes are running. So I have two binds running here, one directly on the host and another one running in a container, and that is the container UID there. Okay, that was atop. So if you want to have the historical data, you should make sure that atop is started as a service in the background as a daemon, because then it writes down the binary data by default every 10 minutes. In this example here, I've changed that to write the data every 60 seconds, so every minute. So I have a more fine-grained history of the system. Takes more storage space, but that's usually not a big problem. And this is how you can replay the historical data by calling atop with -r and then one of the binary files. The binary files are automatically rotated by time. There's one file per day. Already did the live demo. So, and the last one for today is the incident-based traffic capture. So it is very hard to predict when there will be a DNS or network incident. And often the valuable detailed data from the incident is missing. So wouldn't it be nice to have a system that ultimately starts collecting additional data when it detects an incident, even in the middle of the night? So I've created such a system for customers. And that one measures critical system parameters like CPU load, TCP, and UDP query volume on the DNS server, and it can be expanded to like watch for other stuff like number of fragmentations on the network interface, something like that. And then it starts a network capture and or a DNS tab dump whenever a threshold is reached. These scripts should always check the amount of free storage space before starting data collection. I have that in my scripts, but if you change scripts, make sure that you check for free storage space before running the scripts, because before your partitions are run full. And also the script should raise an alarm in the monitoring system somewhere so that people know that there is new data that they should look for. So the first start is a system timer unit that starts every 60 seconds. And that is the TCP dump starter timer. And this timer unit that starts every 60 seconds. And it starts the service unit. And this service unit starts a script, which is called the TCP dump starter. And it takes parameters. -c is the threshold for CPU load. On this case, with I think 20 CPU cores, if the system load is above 12, then it should start, because the normal load, even on high times, is I think 8 on this machine. UDP 32,000. If there are more than 32,000 queries per 60 seconds, it should then start the collection, or if there are more than 1,000 outstanding or current TCP queries seen on the bind name server. And this is the TCP dump starter script. it first sets some defaults, which are in this case the same defaults that we have seen on the command line. The command line switches can override the defaults, but if you omit the command line switches, then the defaults from the script will be used. The interface we will do the capture on. It's ETH0 in this case, and then it's the parsing of the parameters. And then it does the checks. The first check is for the CPU load. So it looks in proc load average and finds there the field for the current CPU load. And if the load is higher than the average or the configured, then it starts the dumping. So it checks with disk free whether there's enough disk free on the root partition in this case, and only if there's enough space free, it then starts the TCP dump. For that, it starts not directly TCP dump, but it starts another script called TCP dump run, which we will see in a moment, which takes one parameter, the number of minutes that the TCP dump should be running, and then the interface on which the TCP dump should be done. Important here is that with the systemd timer and the systemd service, the timer service is made in a way that it not fires every 60 seconds, it fires every 60 seconds after the last time it successfully run. So in the case that the TCP dump is being started, that runs for 5 minutes. And during that time, the timer will not fire again. So you don't have multiple TCP dumps catching the same data. The third checks then for the UDP queries. It uses RNDC to figure out the recursive clients. And the last part checks for the TCP queries, and it also uses RNDC for the TCP clients. And then the checks are the same. It checks whether there's free space, and then it starts the TCP dump. And then the TCP dump run script is quite simple. It does a TCP dump for 5 minutes. That is the uppercase W. And it writes to /pcap/packet trace with date and I think host name in there. And it does so on the interface, which is the second parameter to that. Now, the TCP dump run here on some custom platforms, I have changed this, that not TCP dump is started, but DNS tab is started. That is then be done with RNDC, I think RNDC DNS tab. Okay, so here we have the references, the link to the configuration templates, and the bind administration reference manual on the logging part. More tools for DNS data collection, for passive DNS data collection as an alternative to query logging. And information about the systemd journal and about forward secure sealing and how you can filter your log information with systemd journal. And where you can find atop. Usually atop is in the repository of almost all Linux distributions, and it's also available for FreeBSD. It's not available for OpenBSD and NetBSD to my knowledge. And with that, I'm done for today. Sorry, I'm overrun the time a little bit. This is the upcoming webinars. The next one, again, on log analysis, but this time about long-term statistics, monitoring and log analysis, not incident-based, will be on March the 17th, 1 month from now. Vicky, do we have questions?
Yes, we do. JP has been helping to answer them in the background, but
great.
I think for the people that are still on, we should run through the questions anyway. So Andreas was asking, when storing log messages within different files, like a separate file for Xfer and Notify, how do you correlate them later on? So in this example, you know, which notify caused the transfer.
Yeah, that is if that data is being written to separate files, then it's possible but quite difficult to correlate them with the tools. It's easier when everything goes to systemd journald, but if there's data that I need to correlate, like the notify and the zone transfer, I usually put that into the same file.
Yeah, that's just a downside of putting them in separate files.
Yep.
So there was a question Steve had that has been partly answered. What are the logging parameters that have the biggest impact on NameD's performance? And what do you recommend to minimize the impact? And JP's pointed out that query logging is the biggest hog.
Yes.
Are there others?
Yeah, in general, if you see log entries that you don't really care about but happen very often, for example, on a busy DNS resolver, you might see a lot of resolving errors, DNSsec kind of errors, but these errors usually are not very helpful because they are other people problems. So they are misconfigurations of other name servers out there in the internet. And sometimes they're useful if we analyze a certain problem, but most of the time we don't use that. So I would send these data then to either don't log that or log write that to the null. But better is not to log that because again, creating the human readable version of the text for logging, that takes the most CPU. And if there are errors like, I have some DNS resolvers that log DNSsec errors and resolver errors like hundreds per second. And that is quite work for the DNS server.
Okay, we have a couple of tough questions. Christian has typed multiple views for GeoDNS and how to do zone transfers. So I'm not actually sure what the question is.
I know what the question is, but it's not really fitting in this webinar. And the answer would be an hour time I need to answer that fully. So maybe we should do a webinar on that.
Oh, okay. All right. I thought this was a logging question and I couldn't really see.
Now I understand this is how to do zone transfers with views, because that is
it's not about logging at all. Yeah.
No, not directly, and it's a difficult question a lot of users have.
Right. So here's another question from Jesse. Do you have any recommendations about the size of the various sectors? This is one from when you were talking about partitioning the disk.
A sector size, or that I understand about 512 byte sectors or 4K sectors. And nowadays I would always go for 4 kilobyte, 4069 sectors, if that is the question. Sizes of partitions, that really depends on the size of the storage and the amount of log data that is there. Yeah, there's no general rule. I mean, it depends on how much storage there is and how much space the logging needs.
Yeah, so Anil is asking whether LogEater works with DNS tap data.
No, not at the moment, but it could. Just a matter of changing the tool. So in general, if there are if someone has an idea what LogEater can do or what would be helpful, it's on GitHub. Open an issue, and when I find time, I will implement that.
Or you could submit a pull request.
Or even better, yes.
And then there are a bunch of folks with comments and questions about getting DNS tap support on Red Hat, and Rick has helpfully pasted in a link to issue in the Red Hat bug tracker that says that DNS tap should be coming soon in Red Hat 8.
Okay.
ISC does publish a package for Red Hat that includes the dependencies for DNS tap, so that's another solution. I know, the issue is that Red Hat doesn't include all of the required libraries for DNS tap, so.
Yeah, but it's coming, I understand.
So that's it for the questions, and I just want to thank you. I think this was just an excellent webinar, just really cram full of useful ideas, and thank you also for the live demos. When we post the slides, I will also make sure to post links that people can access to your logging templates.
Thank you. What a pleasure. See you next time.
All right.